We are looking at b, so we have a equals 1/2 h a plus b, and we're asked to solve for a. Now, we have to assume that uppercase A, H, and B are numbers. They are not, but we have to assume that they are known and they are given to us. We only have to solve for A. The A is the only variable. This is the area of a trapezoid. So these are all models from geometry, from physics, from medicine, from all sorts. And we're asked to solve for a particular letter. What I recommend, or what would you say would we have to do first? I would like to get rid of this. Right. So in order to do that, I will have to multiply both sides by? Exactly. So then I have 2a equals h, a plus b, and I'm still solving for a. And now I would like to get rid of, you can distribute if you want to, but I think it's easier if we get rid of it. Yes. So divide by h. So then I have 2a over h equals a plus b, and I'm still solving for a. Therefore, the last step will be a equals
2a over h.
Exactly. That's it. So now please choose another. I would definitely recommend C and D.
Let's do D.
D?
Lots of fractions.
Okay, very good. So we have 1 over r equals 1 over a plus 1 over b. And we are asked again to solve for a. Remember when we looked at those equations, we said, okay, let's move everything to one side to have 0 on the other. Only because really most of the terms and most of the fractions had a variable in it. Here, the variable is only here.
Right.
So if I move everything to one side, it would be slightly more difficult. I will get there eventually, but it will be more difficult. All I want to do is just move this one here. So I will have 1 over r minus 1 over b equals 1 over a. On the left-hand side, I need the LCD.
R, B.
Very good. I need the adjustments for each portion. For the top of the first one, the adjustment will be
B.
exactly what it doesn't have. And for the other one will be
R.
uppercase R. So then the numerator will be
BR.
minus,
R, yeah,
right?
Yeah, B minus R.
B minus R. Now, the variable is only here. I can cross multiply. Let me show you a little trick before we cross multiply. Is this true? I multiply top and bottom by 10.
Yes.
Is 1/2 the same thing with 10 over 20?
Yes.
If you flip this and you flip this at the same time, you will still get a true identity. So here, only because I have 1 at the top. If I didn't have 1 at the top here, I would have probably not done that. But as I have 1 at the top, I can flip both and I get A. RB over B minus R. This is just a minor trick. Do I have to use it? No. Well, let's cross multiply. Let's continue here. So I have A, B minus R, I will not distribute, equals RB. A, B minus R equals RB. And then when I divide, I get this.
Okay.
So A equals RB over B minus R. Which method in homework, which method did you use for rational equations? The method that
I did everything just like we did in here.
in class.
Mm-hmm.
Okay, very good. I think it's easier, although multiplying both sides by products of denominators, that's not difficult. But I think that this is more, it's less writing in a way. But some people don't like it. Some people go back to the method in the book. Okay, let's also do A. I'm sorry, not A, C.
C?
Yes, C is important. So in C we have A equals P plus P RT. And we're asked, this is P, sorry. This is P and this is P. We're asked to solve for P. So remember, I always say, I know I repeat myself a lot, factor simplify should always be in your mind. Okay, so I'm asked to solve for P. What will be my first step? What do you think? Since I cannot combine them, since I cannot simplify, there must be factoring involved.
Okay.
So what could I factor? Exactly. That's my only hope, my only chance, because I can combine P with PRT. Since I have two terms, I have to have two terms in parentheses.
So B1 plus R.
Exactly. And I'm done. And how much is P?
A.
Exactly. Over 1 plus R. Good. So the last section now concerns fractions over fractions. Operations with fractions at the top, operations with fractions at the denominator. It's called complex. They're not called difficult, but they're called complex because I have operations to perform here, operations to perform here, get one fraction at the top, one fraction at the bottom, and then I can flip.
Okay.
That's the whole thing behind it. So let's go back to, this is page 4 from the handout. Let's start with the first one. Complex rational expressions. This is the last section. So 7.7, complex rational expressions. Okay, so let's start with 5 plus 3 over x minus 8, everything divided by 2 minus 1 over x minus 8. You cannot flip in this situation. You have to wait till the top becomes one fraction and wait till the bottom becomes one fraction, and then you can flip. Okay, so I look at the top, I find the LCD, I look at the bottom, and I find the LCD. And I will, for now, I will state only one restriction, that x does not equal
8.
Perfect. So what will be the least common denominator? Nothing is different from what we've done before. Adding fractions or rational expressions with unlike denominators. Same, everything the same.
Okay. So the common would be x minus 8.
Right, there is no other denominator, right. And the denominator is also x minus 8. But this is 5 over 1. So it has to get the adjustment,
Okay. X minus 8.
what it does not have. And the same thing here, 2 over 1. So x minus 8. So now let's write the numerator for the top and then the numerator for the denominator.
5 times x minus 8 plus 2.
Careful. Once we distribute to x, we also have to distribute to 8.
Okay. So 5x minus 37.
40? Yes, you're right.
Oh, yeah.
Yes, you're right. But I just want to write it like this first and then we'll combine like terms. You're right. And then the denominator?
2x minus 16 minus 1.
Excellent. Now I combine like terms at the top, which are perfectly correct. 5x minus 37 over x minus 8. And you're right, in the denominator we have 2x minus 17 over x minus 8. Now I'm ready to flip. I copy the fraction from the top. And now I'm ready to flip the denominator because they are divided. So I copy this and I flip to change it into a product. From here I have to add to the list one more restriction, that x is not 17 over 2. And now I'm free to simplify. And this is the only thing that goes away. There is nothing else I can do here. And this is it. With the restrictions. That's all it is. On all of them, but we need at least another one. Would you like to work on one for a minute? You want to choose one, or you want us to do one more and then we choose one?
It's okay. Let me try one. Let's see.
Okay.
Let's see where we go.
Okay.
How about C?
C. Very good. here where my handouts were. In my book. Ready? Okay. I think we needed one more together before you.
Yeah, I was rolling until it got to factor.
That's okay. That's okay.
I can do it, I'm just so slow.
That's okay. So you're not slow. Obviously, there are three fractions here. You could have considered as one as well, but I think it's easier if I take each term separately. It's not a mistake. I don't know what you did, but it's not a mistake. Obviously, the least common denominator is 2x minus 1 in both cases.
Right.
Obviously, we have x not equal 1/2. Obviously, this one needs a 2x minus 1. This one needs a 2x minus 1, 2x minus 1, and 2x minus 1. Correct?
Right.
X to 2x.
Minus 2x squared,
X to negative 1.
minus x,
2 to 2x.
minus 4x,
2 to negative 1.
minus 2.
And minus 12. That's the top. Agreed?
Yeah.
Okay. Now, 2x squared minus x. 2x squared minus x plus 2x minus 1 and minus 9. Now, I cannot try to simplify anything. That would be a terrible mistake. I'm not saying you did any of that. So here I have 2x squared. Here I have positive 3x. And here I have negative 14. The denominator is 2x minus 1. I can flip 2x minus 1 over, and I have 2x squared plus x minus 10. This will go away. I'm safe because I stated the restriction. And now, yes, I have to try to factor the top, and I have to try to factor the bottom. I don't know if they're factorable. I haven't even looked, but I have to attempt. If they're not factorable, then this is the final answer, this over this. But if they are factorable, maybe I'm hoping I can cancel one factor. And also, if the denominator is factorable, then I have to state two more restrictions here, unless one of them is the same. So 2 times negative 14 is negative 28. So that will be the product. And the sum will be 3. So the 28 is only 4 and 7, right? And that's what I need. So I need a 7 and a negative 4. So then the top becomes 2x squared plus 7x minus 4x minus 14. Obviously, I have an x and 2x plus 7, and then a 2x plus 7, and only now I look, and it's minus 2. So then this is 2x plus 7 and x minus 2. You understand that this would have not been possible without chapter 6.
Right.
Nothing, none of this. So this is 2x plus 7 and x minus 2. Now I have to repeat on this. So I have the product, which is negative 20, and the sum, which is positive 1. So yes, and a 5 and a negative 4 would work. So I repeat. And then I have now 2x squared plus 5x minus 4x minus 10. Again, I do the same trick. I have an x and 2x plus 5 and a 2x plus 5. And now I look, and it's negative 2. Nice. 2x plus 5 and x minus 2. 2x plus 5 and x minus 2. I have 2 more restrictions to write. Not negative 5 halves and not 2. So not negative 5 halves and not 2. And now I'm fine with simplifying. And this is the simplified form. I'm going to write it right here in the middle. 2x plus 7 over 2x plus 5, assuming all these conditions are fulfilled. Does it make sense?
Yeah.
Would you like to work on another?
Sure.
Okay.
So
Let's
back
go
up to B.
B. Very good. So let's work on B.
think I'm good.
Good. So obviously the least common denominator is x squared for both.
Right.
I have x not equals 0. The first one needs an x squared, the next one needs an x. So then the top is x squared plus 3x minus 18. This one needs an x, this one needs an x squared, and this is 21 minus 4x minus x squared. I like everything except this, of course. I copy the top and I factor it already, x plus 6 and x minus 3 over x squared times x squared over the opposite in front. I have to factor out negative 1. And then I have x squared plus 4x minus 21. These two will go away. And now, positive with negative in the denominator will be negative. The top is x plus 6 and x minus 3. And luckily the denominator will be x plus 7 and x minus 3. I have two more restrictions to add to this list, negative 7 and 3. And then 3 goes, x minus 3 goes away. So the simplified form is negative x plus 6 over x plus 7, assuming these conditions are fulfilled. From the review, on page, I just want to discuss one particular type of problem. Or section 7.7, it's okay, I'll copy it from here. Let's say 46, on page 500. A to negative 1 plus 2a to negative 2 over 2a to negative 1 plus 2a in parentheses to negative 1. The question is, what is this? The answer is,
You can come in.
I have to remember,
It's just me. You can come in.
I have to remember, welcome. I have to remember what a to negative 1 means. What does a to negative 1 mean? And the answer is 1 over a plus, what does 2 times a to negative 2 mean? It's not in parentheses. 2 has power 1. 2 cannot go to the denominator. So this will be 2 over a squared. What about 2 times a to negative 1? What will that be? Exactly, plus. Now I have parentheses around 2a and the power is negative 1. How much will that be? Exactly. So now this I know how to handle now. But I have to remember the negative power. Okay, so let's take one moment and work on this and see what we get. And then we are ready for chapter 12. I'm glad you're here because I'm just starting chapter 12 and you will see it twice today if you want.
I'm going to be working on my paper, so I can find it.
Okay,
I can understand it, but I'm getting confused on some stuff.
okay, very good.
Thank you very much.
Sure, my pleasure. So the numerator, a squared, correct?
Yes.
And it needs an a at the top.
Right.
So this is a plus 2. Of course, a cannot be 0. The denominator is 2a. This one has only a, so then it needs a 2. So this is 4 plus 1.
Right.
So the numerator goes at a plus 2 over a squared times 2a divided by 5. There is no restriction for 5. There is nothing to be added here. So the only thing I can get rid of is one of these two a's. One from the top and one from the bottom. So I have 2 in front times a plus 2. There is no need to multiply, divided by 5a. And this is good enough. Perfect?
Yep.
Okay. Very good. Chapter 12. Chapter 12 deals with the following: algebra of functions. These are the major topics. Algebra of functions. Second one, function composition. So algebra of functions, then function composition. Next one, inverse functions. And basically 2 more topics: the exponential function and the logarithmic function. So algebra functions, function composition, inverse functions, exponential function, logarithmic function. So we start with algebra functions. So these are sections 12.1 through 12.3, 12.5, and 12.7. 5 sections. Okay, so 12.1, algebra functions, so these 2 in 12.1. Algebra functions and function composition. So let's discuss this one first. What do we do? What does algebra mean? Well, adding, subtracting, multiplying, and dividing. But this time with functions. Now here's the question. Why would I ever want to add 2 functions or subtract or multiply or divide? For many reasons. Let's say we have, we own 2 stores or 2 shops. And let's say we have a function that gives us the profit for one of them. And we have another function that gives us the profit for the other. But we really want to find the profit, total profit, not just for this one or for this one. We want a total profit. That's when we add 2 functions. The function that gives profit from one plus the profit for the other. That's an example. So if I'm given f of x and g of x, 2 functions. If I want to create f plus g, this is the name of x, is this clear what I really mean that we want to do with these 2 functions? Yes, obviously, this must be f of x plus g of x. That's why we call it this, because it tells us how to find it. If I say, Heather, let's find function t of x, you will say, how? But if I tell you find f plus g of x, I don't have to tell you how, because it's clear. Right? The same thing for f minus g. Nothing else but f of x minus g of x. Same thing with the product. Fg of x means nothing else but f of x times g of x. And f over g of x means nothing else but f of x over g of x. But now I have to put a comma and I have to write if, which I didn't have to do for the first, the second, and the third. But I have to do it for this one. What am I implying here? What am I saying? And that's the reason why I asked all the time, write restrictions so you get used to it. And why? Because the denominator cannot be 0. Why? Because if the denominator is 0, then the function is undefined. So now it should, become a routine. Of course, if g of x is not 0. Because if g of x is 0, I can't create this function. There is a problem, though. So here's a potential problem. When I want to add, subtract, multiply, divide functions. Here's the potential problem. So maybe it's not clear from the beginning, but if this is 3, then this is 3, and this is 3. If this is 8, then this is 8, and this is 8. In other words, for a particular x value, I'm finding f of 8, I'm finding g of 8, and I'm adding them. Okay, so x has to be the same number. So if f, let's say, is this function, this is f, and g, let's say, is this function, they don't have a common domain. So if I ask you, let's say x equals -1, find f plus g of -1, you can say it's undefined. Why? F of -1 exists, but g of -1 doesn't. And I can't add a value to undefined. So if the two functions do not have a common piece of the domain, if they don't have a common domain, there is nothing I can do. I cannot create the sum, the difference, product ratio. So let's look at an example. On page 717, let's say we start with problem 4, where we are given f of x equals x squared minus 2, and we are given g of x equals 3x. And we are asked to find all four functions, the sum, difference, product, and ratio, and their domain. First, I need to find the domain of function f. We know how to graph this function. We'll learn it's x squared. What is its domain?
Negative infinity.
Right. Because it's a polynomial function, it's quadratic, indeed. Then I have to find the domain of function g. Well, I know how to graph this. It's a linear function with a positive slope. What will be its domain?
Negative infinity.
For the same reason, it's a polynomial function. Now question, what is the common domain? Do they have a common domain?
Right.
Of course. Common domain is everything. That's where they exist. They both exist on the same thing, and that is the common domain. So that tells me that I can create the sum, difference, product ratio. We'll see about the ratio, but definitely the sum, difference, and product. So this will always be the common domain is always the domain of the sum, the domain of the difference, and the domain of the product, always. I don't have to find it again after I find those functions. Once I found the common domain, I know it will be the same with the domain of the sum, difference, and product. So now, let's find them. I don't know about the ratio. That part I don't know. I have to create the function and look at it. But definitely for the sum, difference, and product will always be that. But I cannot list the ratio just yet. I have to check it out first. Okay, so let's find the sum. I have to write the definition. So I have this in front of me, so I present what I have to do, where f of x is x squared minus 2 plus 3x. F of x is x squared minus 2, and g of x is 3x. I put this in descending order, x squared plus 3x minus 2, and this is done. Then I create the difference. I have to write what it means carefully because I have to distribute this negative sign, whatever, to g. So then I have x squared minus 2, but minus 3x. Like before, I present this in descending order, and I get x squared minus 3x minus 2. And this is done as well. Then I will determine the product, fg of x, which is by definition f of x times g of x. I replace f by x squared minus 2, and I multiply it by 3x. Yes, I have to distribute 3x, and I get 3x cubed minus 6x. And now this is done. Is it clear why these three functions have this domain? I don't even have to think about it. Once I found the common domain. Good, but now I have to talk about the ratio. That's the last function. F divided by g. By definition, this is f of x over g of x. F of x is x squared minus 2 over 3x. I know I cannot simplify anything. I can't touch it. But I'm asked to find its domain, though. Well, that's a different story. Now I have to state a restriction. And the restriction is? Correct. So therefore, the domain of the ratio is not the common domain. What is it?
Negative infinity to 0, and 0 to infinity.
Yes. Very good. Would you like to work on another example, or can I present the function composition?
The composition.
Okay. So there are 4 ways so far. We studied 4 ways of creating new functions if we are given 2 of them or more, right? I could be given 3. Same thing. So, but with 2 functions, that's the way, sum, difference, product, and ratio. There exists a 5th way, which has nothing to do with this. Totally different. Here is the mechanism. First of all, the notation is f, a circle, and g of x. We read this f comp g, the composite of f and g if you want, or in short, f comp g. Also, the composite of f and g. We prefer the first one because it's quick, f comp g. Of course, we can go the other way, g comp f of x. Of course, we can compose f with itself. Of course, we can compose g with itself. I can compose f with g again. We're really interested in these 2, and these may pop up as well. But how do I do this? This is very clear. I do this. This is very clear. I do this. This one, and so on and so forth. I do this. But how do I do this comp? Here's how I do the comp. So f comp g of x, g is the closest to x, and I'm applying f to it. How do I read this? F of g of x. In other words, to find the composite of f and g, I take g and plug it in x as if it's the independent variable. How do I find g comp f then?
G of f of x.
That's it. However, there is no discussion of the common domain here. There is no common domain requirement for this procedure. So let's talk about the first one. So to x, I apply g. To x, I apply the function g, and I get g of x. This is a number. So g I apply to 5, and I get 10. What do I do with 10? I have to plug it in f. So then, to this number, I apply f to find f of g of x. Now, like before, when I wrote here, there is a potential problem. With the sum, difference, and product, the potential problem was not having a common domain. But here is, and we do not have to determine in this class the domain of the function composition. We do not. But here's what could go wrong. For function g, this is its domain. What is this? Where the y values are coming from. Right. But this set is what for f? Right. So they may not work well together. So for example, g may bring here 5, but if f is not applied to 5, I'll never get here. So the range of g and the domain of f have to work well together. If they don't, if I bring a value here that f cannot be applied to, I can never get to the end. The chain is broken. We do not have to do this in this class, but we have to practice determining the function composition. We already had a problem, so let's continue and find for the same two functions the function composition both ways. Okay, so I'm copying the same thing. I have f of x equals x squared minus 2 and g of x equals 3x. And let's find any function composition we want. Let's find f comp g, let's find g comp f, let's find f comp f, and let's find g comp g. All four. Okay. So for f comp g of x, I have to write the definition, which is f of g of x. Now, here's what I do. You don't have to erase it like that. I'm just making a point. This will get replaced by this. So this is f of 3 times x. Then I look at function f and try to decipher what it tells me. Function f says f of whatever is whatever squared minus 2. So f of whatever will be whatever squared minus 2. This is my whatever now. So this is my new x value. So this will be 3x squared minus 2. And I do have to square 3x, and I get 9x squared. And I'm done. That was the function composition, f comp g. Now I want g comp f. You want to work for a second on this? On g comp f? Okay. Good. So this by definition is g of f of x. So now I replace f inside g. And I look at g. G says 3 times whatever. This is my new whatever. So I have 3 times whatever, which is 3x squared minus 6. Okay, let's choose one more, like either g comp g or f comp f. Let's do f comp f. Okay, 1 minute. So this is definitely f of x. So now I replace this by f of x. And then I look back at f of x and says f of whatever is whatever squared minus 2. Now this is my whatever. So I have x squared minus 2 squared minus 2. But we have an agreement on this, and I know that when I square a binomial, I get, very good, first term squared, x to the fourth, minus 2 times the first times the second, 4x squared, plus 4 minus 2 is plus 2. And this is done. So this is the function composition, f comp f. Now, I don't know how far you need to get into math, but this is an important topic right now. Function decomposition. We just did the composition. Are we going backwards? Yes. So now I'm given a function. I will be looking at it and say, I know. I can create two functions whose function composition is the function you give me. So I'm copying 33 on 717. Age of x equals the square of x plus 5 plus 2. For function decomposition, there is more than one correct answer. You can come up with two functions whose composition is this, and I can come up with totally different functions whose composition is this. So there is more than one correct answer. So I'm looking at this function, and I'm asked, find two functions. Find f and g such that this function will be f comp g of x. So what is very important to understand is this is called the inner function, meaning the function that I will apply first to x first. And this is the last one. We'd like to write it as call it as the outer function. Of course, this is based on the order of operations. So now let's look at age of x. It has x plus 5. It has the square root, and it has plus 2. So if I'm asked to evaluate this function for x equals 1, by the order of operations, I have to add 1 to 5. When I'm done, I apply the square root to that number. When I'm done, to this number, I add 2. So I already told you 3 functions, but we only need 2. So now we can come up with whatever you want. What will be the first function that you would apply that I would consider the inner function? And again, there is more than one correct answer. That's it. That's correct answer. That's your first function. When you're done with that, you get one number as the result. And now I want the function that is outer that you will apply to one number. So this is a number. Exactly. Exactly. And let's create the function composition to convince ourselves that we will eventually get h of x with the two choices, with these choices of g and f. We don't have to do that. It's clearly it's going to happen, but let's convince ourselves that it's going to happen. So let's calculate f comma g. By definition, this is f of g of x, which is f of the square root of x plus 5, which will be based on f that says whatever plus 2. How do I write whatever plus 2? That's it, and that's how we started. Here's another. Let's say 35. We are given h of x, 1 over 2x minus 3. we're asked to determine two functions, an inner and an outer, such that f comma g is this result. So let's find the inner function first, the function that we will have to calculate first if we were to evaluate h. If I'm asked find the value of h when x is 5, I will definitely calculate what first? Yes, you can consider 2x if you want. You want to do 2x? That's fine. Good. So now I got a number here, so I need to find another function. Which is the last function that I will apply? I have one number, but 1 over. 1 over x minus 3. Can we find another g and another f of x? What is another option? We don't need a second option. I just want to discuss another option.
X minus 3.
Excellent.
And then 1 over x.
Exactly. Awesome. I like a problem like 43, and then we can move on. F plus g of 2. And we are given f of negative 1 is 4. Not everything is useful here, but I'm copying all of them. F of 2 is 7. F of 7 is 1. G of negative 1 is negative 4. G of 0 is negative 3. G of 2 is negative 1. And G of 7 equals 4. We're asked to find f plus g of 2. And then I'd like to add one more, like 46. With g come f of 2. And then we can continue with the next section.